The first topic we're going to cover is naming elements and ions. So the first thing we have to navigate is just the basics of the periodic table. And the first thing you're going to look for on the periodic table is this big dividing line. You go down, over, down, over, down, over, down, over, down, over, down. Okay? Shade in all of the elements above that line and all the elements below that line except for the very last one. Okay? We call those elements the metalloids or the semimetals. Everything to the right of the purple are called nonmetals, and everything to the left of the purple are called metals. Now, there are a couple of special metals that their families are given a name. A family is a column. So the very first column is called the alkali metals. The alphabet starts with the letter A. The very first column is the alkali metals. Okay? The second group are the alkali earth metals. So the second column has two words, alkali earth. Alkali earth has two words, and it's the second column. All the metals in the middle we call the transition metals. So this area over here are called the transition metals. These are the lanthanides, or the lanthanoids. These are the actinoids. And in the very last column are called the noble gases. And these are the halogens. Okay? So those are the parts of the periodic table that you have to memorize. Okay? And then you have to regurgitate this from memory. So given a blank periodic table, you have to label this completely. Okay, this is really important. The next thing is to name elements. Now, most elements just go off of the first one or two letters of their name. For example, helium goes by He. Calcium goes by Ca. However, there are a few elements that you'll notice that go off of their ancient Latin names. And so you need to memorize the ancient Latin names of these elements. And I'm going to write the list. So you've got sodium is Na. Potassium, K. Iron, Fe. Silver, Ag. Gold, Au. Mercury, Hg. Tungsten, W. Lead, Pb. Tin, Sn. Antimony, Sb. Oh, almost forgot copper, which is Cu. So these elements go off of the old Latin name. Iron used to be called ferrum, silver, argentinum, gold, aurum, mercury, hydrogenum, tungsten, wolframite, lead, plumum, tin, stannum, antimony, stibium, and copper, cuprum. But we don't use the old Latin names anymore, but we still use their symbols. Okay, so that also has to be memorized. Now, every single element on the periodic table can be found as a single atom, except for a few. So it is possible to have a single atom of lead. It is possible to have a single atom of gold. But there are some elements that are only found as Siamese twins, I would say. We call them diatomic. Di means two in Latin, as pairs of atoms. And those are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. If you go back up to the top of the periodic table, you'll see the magic 7 are hydrogen right here, and then the halogens, which are these, then oxygen and nitrogen. So they're all kind of found together there. In fact, they kind of make an upside down L over here. Okay? And then hydrogen over there. So all of these are found as two atoms linked together. Okay? And then there are two elements that do foursomes. They are, or I should say, polyatomics. Phosphorus is found as a foursome, and sulfur is found as an eightsome. So phosphorus and sulfur are not found as single atoms, and they are located right here on the periodic table. Okay? So all of this stuff is memorization, because we just, certain things we have to just memorize in science. Some things are skill-based. This is one of those things that are memorization-based. So the metals, they tend to form positive ions. They also have low melting and boiling points. And they also are shiny. They conduct. They're malleable, which means you can bend them without breaking. And they're ductile, which means you can turn them into wires. Okay? Nonmetals they're kind of the opposites. They form negative ions. They have high melting and boiling points. They are brittle, dull, and do not conduct. Okay? So, what about the semi-metals, or the metalloids? They show properties of both. So they're kind of in between. Okay? So elements, when they are by themselves, they're typically neutral. Okay? But there are, when they form an ion, they develop a charge. Now, they become charged by gaining or losing electrons. Okay? Now, when they have a charge, they have a different name. So we're going to begin with things that form positive charges. Okay? We call these cations. Okay? How do I know they form cations? Well, write the little positive symbol, and then it makes a little cat. Okay, so positive charges form cations. If you think I'm mistaken, you're wrong. I'm very certain about this. You could even say I'm positive. Like a cat. Get it? Positive? All right, that was my attempt at a joke. So anyhow, if you've got a cation, let's say, let's compare these two, okay? The top one is just sodium, just plain old sodium. The second one we would say is sodium, okay? You write the name and then you add the word ion. Okay, so the top one is just plain sodium. The one with the 1 plus charge, that is a sodium ion. And they are very, very, very different substances. Okay, so sodium, the top one, is deadly. Okay, if you swallow sodium, it'll burn a hole through your stomach and kill you. Whereas the bottom one, sodium ions, are essential for your nervous system to function correctly. And if you don't get enough sodium ions, your nervous system will fail. Now, in modern day diets, it's pretty much impossible not to get enough sodium. There's sodium in everything we eat. But in ancient times, sometimes people would be salt deficient. Salt was a valued commodity. So for positive ions, you write the name, and then you add the word ion. So something like this, Al is aluminum, and you'd write the word ion. Now, how did I know to write a 3 plus there? Well, if you look at your Appendix A, which you'll pick up, it shows you that aluminum's got a 3 plus charge. Otherwise, you would know the charges from the periodic table. The very first column has a charge of +1, +2, +3, +4, then it counts down -3, -2, -1, 0. All the transition metals, those guys you have to look up on Appendix A. But at least the major columns, which is 1, 2, and then 13 through 18, those are the major columns. Those you can just memorize. So everything in the very first column has got a +1, everything in column 2 has got a +2, everything in column 13 has a +3, then +4, and then it counts down -3, -2, -1, 0. And since aluminum is right here, aluminum has a +3 charge. Okay? How about, let's name this one. Hey, wait a minute, Mr. Strauss. Didn't you tell me that hydrogen was one of those that has to be diatomic? When it's neutral, it must be diatomic. We call this hydrogen. The top one we would call a hydrogen ion. When it has a charge, none of them have to be, none of those magic 7. Here are the magic 7. And here are these two. When they've got a charge, they do not have to be diatomic or polyatomic. They can be by themselves. So if it's neutral, like this one, it must be diatomic. When it's got a charge, it does not have to be diatomic. Okay? So what about the negative ones? The negative ions we call anions. Okay? And here you write the word, or write the name, but you change the ending to IDE. and then write the word ion. So for example, if we had, say, let's compare chlorine and so Cl2 we would say is chlorine. Okay? Right? It's one of the magic 7, it's diatomic chlorine. But what if we have this, Cl minus 1? Well, we write the name, chlorine, then we change the ending to IDE, and then we write the word ion. That's a chloride ion. And once again, this thing is very different than that thing. A chloride ion is also essential for nervous system function, whereas chlorine is a poison deadliest gas. So if you breathe in chlorine, you die. But you need to eat chloride every day. Okay? And usually you get chloride from sodium chloride, which is table salt. How did I know the charge? I'll go back to the periodic table. Where's chlorine? Chlorine is right there. Kind of hard to see. The chlorine is in the -1 column, so it is a -1 charge. How about this one? P4 and P3 minus 1. P4 is phosphorus. P with a -3 charge, well, then you have to change the ending to IDE. So phosphorus becomes phosphide. And then we write the word ion. Okay? So those are the basics of the first topic. So after watching this video, then you should do the first assignment.